Right, Year 12, I'm going to go through question 13e from Extension 2 paper 2017. Now, before I jump into this, I'm going to explain a little bit about vectors. So remember that a vector is a modulus with a direction. So there's a vector v1. That's the same as this vector, as long as it has the same modulus and the same direction. It doesn't matter where I put it. These are all the same vector, as long as they have the same direction and the same modulus. Where I place that vector, according to some arbitrary number plane or Argand diagram or some position in space, well, that's up to me. Now, the other thing you need to know, if I want to add two vectors, so here's v1 and here's v2. Well, I just move v2 over to here and I get a new resultant vector, v3. Okay? So v3 equals vector 1 plus vector 2. The other thing you need to know is if I wanted to go down here, if I wanted to go the opposite way to v2, well, I can do that. I just add negative v2, because that's just the negative just tells me it's going the different direction, and I get a different resultant. I'll call it v4. v4 equals vector 1 minus vector 2, which is just adding vector 2 in a negative direction, in the completely opposite direction. So now that we know that vectors can be anywhere, and now that we know we can add two vectors to get another vector, let's have a look at the problem. So they've told us to use vectors, and they've told us that A, B, C, and D are represented by complex numbers. So let's just have a look at DC. So I'll draw DC. Here it is, the vector DC. I'm going to write up here, DC. I'm going to put an arrow because the direction is important. It's going that way, from D to C. Your starting point is important. Well, I already know that that is D. And I know that is C. That's what they told me. They're the complex numbers. Now, I want the vector DC. So to get the vector DC, if I take the vector C and add the negative vector D, I will get this vector, which is the same as DC. So DC equals D minus C. The complex number D, sorry, got them the wrong way around. The complex number C minus D. And remember, the position of the vector doesn't matter. I'm just using vectors. The vector DC is equal to the complex number C minus the complex number D. Let's have a look at AD now, or DA. So let's take it as DA, that vector. How do I get there? There's a complex number D, and here's the complex number A. Now, I want to get back. So what I'm going to do is I'm going to take the complex number D and I'm going to go the opposite direction. I'm going to take negative D. And that will give me the same vector as dA, but here. So the vector dA can be written as A minus D. So now we've got that. Let's go back and have a look over here. The vector DC, I'm going to just move in on that because I've made a complete mess of that. The vector DC is the same as the vector dA. It's just DC is dA moved 90 degrees this way. Well, that's okay. I know how to move things on the number plane. I know that if I want to rotate this way, I multiply by I. And if I want to rotate back the other way, I just multiply by negative I. So now I know that. Let's put it all together. So DC, that vector, equals dA, that vector, times negative I. Well, DC is C minus D, and dA is A minus D. And if I multiply by negative I, what do I get? Well, I'm going to leave this C minus D alone. Equals negative AI plus DI. Move the D over. So C equals negative AI plus DI plus D. Factorise out the D's, so negative AI plus D outside of I plus 1. Tidy it all up and we get C equals D 1 plus I minus AI, which is what we wanted. Now don't get put off by vectors. They're just a direction and a modulus. They're just a direction and a modulus. And when you represent them with complex numbers, you're okay. Hopefully that made it a little bit clearer. Hoping now for tomorrow's exam, you're not going to get put off by the vector notation and how it works. Anyway, good luck.